Hey guys, this video is about electronegativity, the last periodic trend that we're going to cover. Electronegativity is an interesting trend. Okay. Now, electronegativity is a measure of the ability of an atom in a chemical compound to attract electrons from another atom in the compound. All right. It's going to be measured in Paulings. It's a unit that Linus Pauling, the scientist, came up with. Now, there's a measure of electronegativity, and it's basically the power to attract electrons. Some elements are higher than others, okay? There's a basic scale that we're going to essentially look at, all right? So it's more or less a tug of war when you have two atoms put together. Which atom is going to have more of a pull than the other? That has to be figured out, and it's through electronegativity. Okay, now, in the movie Star Wars, the Death Star has a beam called the tractor beam. When ships come within a certain vicinity, the Death Star can shoot out a tractor beam which grabs a hold of the ship. Okay, the tractor beam is very strong. It pulls the ship into itself. Okay, therefore the ship cannot escape. Very similar to electronegativity. All right. Yet, as you know from the movie, Obi-Wan Kenobi was able to actually break the tractor beam, so his power was a little stronger. Now, the measurements, very simple, range from 0 to 4. 4 being extremely electronegative and 0 being like nothing. Okay. Now, noble gases are at a 0. They're not going to be included at this. They are not going to have any kind of pull on anything whatsoever. And part of that reason is because they are stable. Now, when you look at the electronegativity table, you're going to find that the elements that are lowest are found at the bottom left-hand part of the periodic table, and the ones that are extremely electronegative are going to be found at the way right, towards the top. Now, what causes this electronegativity attraction? Well, it has to deal with the electrons that surround the atom. They're known as the valence electrons, and we're going to discuss that the next chapter. So essentially, what goes on is the outermost electrons that surround an atom is what attracts another atom's electrons. So there's this field of negative energy that pulls on the electrons from another atom. Okay, it has a very strong attraction force. Okay, so here we have the electronegativity table. Okay, we have on the left side, it's very low, less than 1. Then as you go from left to right, it increases. Okay, and as you go from top to bottom, it decreases. Now, most textbooks are not as elaborate as this table I'm showing you right here. The one in your textbook is basically missing the transition metals. So this table here is a lot nicer to look at. You can see the trend a lot better going left to right. A lot of these can be found directly right online. Now let's do some comparisons here. You have fluorine on the right, which is 4.0. Lithium has a 1. So what's going to happen in a chemical bond when lithium and fluorine come together to make, say, lithium fluoride? Fluorine is going to have a stronger attraction to the outermost electrons that lithium has. So fluorine is going to pull lithium's electrons into its valence shell or its half-filled orbitals, okay, because it has a higher rating. And the same thing like sodium and chlorine, sodium chloride. Chlorine is going to attract the electron from sodium and pull it into its valence shell, making that bond. And we're going to talk about the different kinds of bonds in the next coming chapters based on the electronegativity differences between the two atoms. It's pretty neat how it works. There's a scale that we look at for reference. Okay, now, as I spoke, as you move to the left to right across the periodic table, electronegativity increases across periods. As you move down the periodic table within a group, electronegativity decreases. So now let's look at a couple questions here. Look at these pairs. In each pair, which element has a larger electronegativity? So pause the video. Okay. Look at each one of these and circle which one is correct. So you can see that in each pair, I've marked the correct answer in red. So we have sodium, chlorine, nitrogen, and selenium. All right, so that is electronegativity and the last trend we're going to cover. All right, guys, talk to you later.